Right, we're carrying on with our study here, and we're looking now at question 28. Let's take a look. This is question 28 on page 88, page 89, sorry. So let's look at what we've got here. We've got some function. It's not a function we're familiar with. It's actually one that we're going to come across when we study calculus, all right? But here it is. And at the moment, it's got three different roots. It's got roots of -2, 4, and 7. Remember, roots are x-intercepts. Now, look at this equation. Is this going to involve a horizontal left-right shift or a vertical up-down shift? And absolutely, it's going to involve a left-right shift. And it says, what could we make t to have three roots of the same sign? At the moment, we've got one negative one and two positive ones. Do you agree that if we move this graph far enough to the left, all the roots will be negative? Or if we move it far enough to the right, all the roots will be positive. Let's do the left one first. How much would we need to move it to the left, all right, to have all the roots positive? We would need this number over here to be over there. So we would need to move it more than 7 left. Okay, and how do we move a graph left? We add. So to move it more than 7 left, we would need t to be bigger than 7. If t was even 7,1, all the roots would be negative. All right? Or the other possibility is to move it more than 2 to the right. How are we going to move it more than 2 to the right? Now remember, to move it to the right, we need a negative number. So we need t to be negative, like -2,1, -2,3, -3, -5. T must be less than -2. Okay. Right. Now, what should t be if we want to have two negative roots and one positive root? Well, to have two negative roots, we would need to move this point more than 4 to the left. All right? So t would need to be bigger than 4. But we can't move it more than 7 to the left. Right? So t would need to be less than 7. If t was in between 4 and 7, let's just think about that. So for example, if we moved it 5 to the left, do you agree that we would have two negative roots? Because this one would now go to -1, and this one would go to -7, and this one would be at 2. Okay, it just requires a bit of thought. It's not that straightforward, but it's not impossible. Right, now we're going to give, and we'll just ask you to pause the video and try, but what must we do to this equation to move the graph 3 left and then 2 up? So pause the video briefly, have a go, and then we'll let it play again and see how you went. Okay, so to shift a graph 3 to the left, we need to add 3 to every single x value. All the x's must have 3 added to them. And to shift it 2 up, we must add 2 at the back. That adding 2 at the back is shifting it 2 up. Shifting it 3 left is achieved by adding 3 to all the x's, in this case both the x's. Right, that's the answer, but it's not in standard form. The question does say in standard form. So we're going to have to multiply this out. X squared, we're going to get 6x here, plus another 3x, we're going to get 9x. We're going to get 9 here, plus another 9, that's 18. Minus 5 is 13, plus 2 is 15. Right, that function there is the previous function, shifted left 3 and 2 up. Right, How do we reflect a graph in the x-axis? Well, we put a negative in front of every y. So in other words, think of it like this. However, we don't want that negative there, so we're going to multiply both sides by negative. Basically, it's going to be that. Either that or that, if we distribute that negative in. Okay. How do we reflect a graph in the y-axis? Well, that's very easy. We just put a negative in front of every x. So 7 over negative x plus 3 minus 2. And how do we reflect a graph in the line y equals x? When do graphs reflect in the line y equals x? When we've got the inverse. So how do we find an inverse? Let's remember that. We're going to swap x and y around. X is 3 to the y minus 5. Now we're going to solve for y. So we add 5 to both sides. X plus 5 is 3 to the y. Now, sorry, 3 to the y, not y. 3 to the y. Now we want to get y out of the exponent. We're going to use logs. Y equals log base 3 of x plus 5. That is the inverse of the other graph, and because of that will be a reflection in that line y equals x. Right, turn over, pause the video briefly and see if you can try this question. So now we're looking at kind of interpreting two different functions and seeing what's happening. Okay, so we've got f, the parabola, g, the straight line. When we talk about f of x, remember what we're talking about actually? We're talking about the y value of f. And when we talk about g of x, we're talking about the y value of g. Now, how do we get a negative product? We get a negative product by having either f of x positive while g of x is negative. Okay, so in other words, we want f to be positive. F positive while g is negative, or the other way around. F negative while g is positive. Now, what does f of x negative look like? F of x negative looks like f above the axis and g below the, sorry, f of x negative, f below and g above, or f above and g below. We need them to be on opposite sides of the axes. So let's have a look. As we come in from here, they're both above the axis. Now from negative 4, the parabola is below and the straight line is above. So from negative 4 up to negative 3 over 2, they are on opposite sides of the axis. So it's less than negative 3 over 2. After negative 3 over 2, they're both below the axis. They're still both below the axis here. From 2 onwards, the parabola is above and the straight line is below. So that's the full solution to that. Okay, now this is, and I'm going to show you another way of doing it. We could write on here the signs of this parabola. So this is positive, positive, positive. I'm just doing the parabola with a red pen, and then negative, 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 positive, positive, positive. Okay, this is not the way I would do this, but it is a way that some teachers teach. This straight line is positive, 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 still positive, 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 and now it's negative, 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 negative. Okay, and now we want to look where will we get a negative product. And here they're both positive, all right? But from here, we've got negatives on the parabola and positives on the straight line up to there, all right? And then obviously from here onwards, we've got positives and negatives. Okay, right, let's take a look now at the next one. The next one is a quotient, but this time we want a positive answer. Now we're going to get a positive answer if both are positive or both are negative. Right. Both positive or both negative. In other words, we need them to be on the same side of the axes. Now, they're on the same side of the axes up to -4. Right, up to -4. Now, careful, at -4, the parabola is actually 0. And so we can't include -4. So x is less than -4. Now, the reason we can't include -4 is because we would have a 0 on the denominator, and this fraction would be undefined. After that, they're on opposite sides of the axes, but from -3 over 2, they're both on the same side of the axes until 2. Okay, we cannot include 2, right? Because 2 would give us a 0 on the function f, it would give us a 0 on the denominator. But we can include the -3 over 2, because that would give us a 0 on the top, and a 0 divided by something is 0. Okay, so that's quite tricky, but remember we get a positive product or quotient if the signs are the same, and we get a negative product or quotient if the signs are different. Okay, we'll do more practice of this as we go. Let's look now, where is f bigger than g? In other words, where is it above g? Okay, and that's quite straightforward. F is bigger than g, all right, to the left of -4, less than -4. All right, after that it drops down below, the parabola is below the straight line, up to, after 1, the parabola is bigger again. So the two possibilities here, x less than or equal to -5, we can make it less than or equal to, because at that point they will be equal. At that point they are equal. But if we go less than -5, the parabola is above the straight line. Or if we go bigger than 1, bigger than or equal to 1. Right, now it asks, for which values of x will this function have two roots of the same sign? Now, at the moment, these graphs intersect at a positive x value and at a negative x value. Right, that's as they are. What is this going to be? Is this going to be a left-right horizontal shift or a up-down vertical shift? Yeah, it's a left-right shift. Okay, but both graphs are going to be shifted. So the question is, how much can we shift both graphs left or right so that the points of intersection have the same sign? At the moment we've got a -1 and a +1. Do we agree that if we were to shift this whole picture more than 1 to the left, then this point would now be negative, and that point would obviously still be negative. More than 1 to the left. How do we shift a graph to the left? Well, we add, so k must be bigger than 1. All right? If k is bigger than 1, this whole picture, both graphs are going to move more than 1 to the left. The other possibility is to move it more than 5 to the right. Now, so remember, to move it right, we would want numbers like -6, -7, -8. We would want numbers that are less than -5. All right, because if it's -5, we would move 5 to the right. We actually want to move it more than 5 to the right. With these things, you need to actually play around with some numbers. Think about -4. No, that wouldn't be enough. Think about -5,1. Yes. All right, so we want to be more negative than -5. All right, we're going to stop there and we will pick up in the next lesson. But the next lesson is a little bit simpler. Before we see you then, try these questions on page 31. Have a great day.